Bismillahirrahmanirrahim. Assalamu Alaikum, dear student. Welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus physics SSC2 unit number 12 geometrical optics. Today we will discuss SLO base according to FBISC requirement numerical problems. Question number 1 to 5 in part 4. Now we can solve question number 1. In question number 1, the given statement is that a distance use of a concave mirror. Here we can use a concave mirror with a focal length of 2 cm to examine smooth teeth. If the tooth under the examination is 1.1 centimeter high and mirror is placed at 0.9 centimeter, calculate the distance of image formed and the height of the image and also find the magnification. First of all, according to the given statement, write the given data. Now, given data, focal length f is equal to 2 centimeter and also height of object, that is denoted by h naught, is equal to 1.1 centimeter and distance of object d naught, that is equal to 0.9 centimeter. Here we can calculate that. So required data, first of all, in first part, distance of image di, and in B part, height of image hi and magnification m. Now, first of all, in solution, we can find the distance of image di. Now we can using the formula, as it is knowing that 1 over f is equal to 1 over d naught plus 1 over di. This implies that 1 over di distance of image is equal to 1 over focal length minus 1 over distance of object. Now putting the values, then 1 over di is equal to 1 over 2 minus 1 over 0.9. Now taking the LCM, then both digits are multiplied. 2 multiplied by 0.9, that is equal to 1.8, and in numerator 0.9 minus 2. So this implies that 1 over di is equal to minus 1.1 divided by 1.8. This implies that di is equal to 1.8 divided by 1.1, taking the reciprocal on both sides. So di is equal to minus 1.8 divided by 1.1 is equal to minus 1.64. Here the first part answer is distance of image is equal to minus 1.64 centimeter. Now we can calculate height of image. In second part, B part, we can calculate the height of image, as it know that hi over h naught is equal to di over d naught. Using this formula, so hi is equal to di over d naught multiplied by h naught is equal to minus 1.64 divided by 0.9 multiplied by 1.1. Now solve this part. So hi is equal to minus 2 centimeter. Now in last part we can calculate the magnification. So as it knowing that m is equal to hi over h naught. This implies that m is equal to hi over h naught is equal to minus 2 divided by 1.1, that is equal to minus 1.8. So the magnification power is minus 1.8. Now in second numerical, the given statement, a convex Scotty mirror is a warehouse has a 0.50 meter focal length and 2 meter tall, so it's 5 meter from the mirror. What is the image position and image height? Now we can write the given data. First of all, focal length f is equal to minus 0.50 meter and height of object, that is equal to h naught, is equal to 2 meter and distance of object d naught is equal to 5 meter. Now according to given statement, calculate the image position and image height. So required that distance of image di and height of image hi. Now according to solution, as we know that 1 over f is equal to 1 over d naught plus 1 over di. This implies that 1 over di is equal to 1 over f minus 1 over d. Now we can putting the values, then 1 over di is equal to minus 1 over 0.50 minus 1 over 5. Here taking the LCM, so denominator or multiply 5 multiply by minus 0.50 and in nominator 5 plus 0.50. Now the answer is minus 5.50 divided by 2.5. Now we can calculate that reciprocal on both sides. So di is equal to minus 2.5 divided by 5.5. So the distance of image di is equal to minus 0.45 meter. Now we can calculate height. So using the formula, as it know that hi over h naught is equal to d naught over di over d naught. So this implies that hi is equal to di over d naught multiplied by h naught. Putting the values, then minus 0.45 divided by 5 multiply by 2. So the answer is hi is equal to minus 0.18 meter. Now in question number 3, the given statement is that if the speed of light in kerosene oil is 2.08 multiplied by 10 raised to power 8 meter per second, calculate the reflective index. So given data, speed of light in kerosene oil V is equal to 2.08 multiplied by 10 raised to power 8 meter per second. Now speed of light in vacuum C is equal to 3 multiplied by 10 raised to power 8 meter per second. So in our reflective index, the reflection N is equal to question mark. Now we can put that, as we know that N is equal to C over V. Here putting the values, 3 multiplied by 10 raised to power 8 divided by 2 multiplied by 2.08 multiplied by 10 raised to power 8. Solving this, that is equal to 1.44 multiplied by 10 raised to power minus 0. Here any power 0 is equal to 1. So 10 raised to power 0, that is equal to 1. So n is equal to 1.44 multiplied by 1. That is reflective index N is equal to 1.44. Now, in question number 4, the given statement, find the index of reflection from a medium 2. If the medium 1 in air with the index reflection is Na, that is equal to 1. The incident angle is 30 degree and the reflective angle is 22 degree. Compare the result with the table and identify the nature of medium 2. Now, given data that is equal to reflective index of air N1 is equal to 1 and angle of incident that is equal to 30 degree and angle of refraction is 22 degree. Now, required that reflective index of the medium 2 that is denoted by N2. Now we can use the Snell law N1 sin theta 1 is equal to N2 sin theta 2. Here N2 is equal to N1 sin theta 1 divided by sin theta 2. So this implies that N2 is equal to N1 sin theta 1 divided by sin theta 2. Putting the values N1 is equal to 1 multiplied by sin 30 degree divided by sin 22 degree. Now sin 30 degree is equal to 0.5. 0.5 multiplied by 1 that is equal to 0.5 and sin 22 degree is equal to 0.375. Now N2 is equal to 0.5 divided by 0.375 that is equal to 1.33. In comparing the table, so this reflective index, the value of 1.33 is the reflective index of water. Now we will move the today last question in question number 5. What is the critical angle for a light traveling in a polystyrene, a type of plastic, with the index of refraction is 1.49. Pipe surrounding by the air, take the index of refraction of air is 1. Now, according to the statement, write the given data. In given data, reflective index of polystyrene that is equal to N1 is equal to 1.49. Now, the reflective index of air that is equal to N2 that is equal to 1. Now, according to the given statement, required that critical angle that is denoted by theta c. Now, we use the formula sin theta c is equal to N2 divided by N1. Now putting the value sin theta c is equal to 1 upon 1.49. Now 1 divided by 1.49 is equal to 0.671. Here sin theta move on other side, it will be the sine inverse. This implies that sin theta c is equal to sine inverse 0.671. Now taking the sine inverse of 0.671 that is equal to 42.2 degree. Best of luck. Remaining video in remaining lesson with remaining numerical. Best of luck. Allah.